Welcome to my video series of database management system. In this video, you will be learning about ER model, entity relationship model or entity relationship diagram in database management system. You will be learning about why, what is an ER diagram or model, why we need the ER diagram or model in database management system, geometrical shapes or the different shapes being used for creation of a diagram in of ER diagram in database management system, components of ER diagram in database management system. So I request you, please stay tuned till the end of this video. Please subscribe to my channel, like and share this video. Thank you. In this video of ER model, I will be training you how to create an ER model or a diagram of a given situation of a database. So in this, let's consider whenever we create a table in database directly and do the designing work without any modeling tool or language, then database will face many issues, problems when it comes to any update in the design of a table. So that's the reason we use ER model or ER diagram. I will be explaining you this with the help of an example. Let, let's see why we need the ER model. Why we need the ER model in database management system. So to explain this, I will be taking an help of an student table. Let's consider I have created a student table in some database, student database. So without having an ER model, what ER model will do? ER model will give the blueprint as we create the blueprint or the architecture on the paper before constructing any house. So the architecture will be called as a blueprint to create any house, physical house. After creation of the house, you cannot make the changes. So on the map, on the blueprint, you can make the changes, which room will be coming at which location, where will be the hall, where will be the balconies, where will be the gate, where will be the parking, each and everything you are going to design on the paper. Once the design is done, you are going to go ahead with the construction part. So ER model is going to give us the blueprint of a database. Once the blueprint is ready, we can go ahead with the creation of the table. So let's consider this student table. What I have created is on the screen is created without using ER model approach. So as you can see, the different fields here in the table: student roll number, student name, and marks in various subjects like mathematics, physics, computers, and English. So in this table, primary key is student roll number. So I have created this table. After creation of this table, a requirement comes that an email address should be added to this table. An email address should be added to this table. Is it possible after creation? No, because this table has not created with ER model. So I cannot create, I cannot insert this. So this is a problem. So let's see how our ER model will look. So let's consider the same thing. Student, okay, student table. I have this is an student entity. In tables, it will be called as student table. In ER model, student will be called here as an entity. With respect to this entity, I have a roll number, I have a student name, I have an email address, subject as mathematics, physics, computers, and English. All these are the different fields of this student table. So student is an entity, whereas roll number, student name, email address, and subjects mathematics, physics, computers, and English are the attributes of this entity student. So these are my column names or field names or attributes. Coming to column names or the field names, we will be calling them when we are having a table. So whenever we are going to have this entity relationship model, we are going to call all the column names with the attribute. As an attribute, we are going to call them. Whereas table name is a student. So student is an entity and their attributes are the column names. So let's see this more in detail. So as we know, this is a table name or the entity. Let's consider our same problem. If I want to have many more columns in my conceptual model, that is blueprint. So how can I get this? So simply I have to add a different attributes to my existing entity. Easily I can add. So in this way I can add the different attributes. Whereas in the physical table I cannot go ahead with that. So this student entity attribute or entity relationship diagram will help us to create more and more in detail conceptual model related to any entity. So that's the reason we need the ER model. Why we need an ER diagram? ER model. ER model helps you to define terms related to entity relationship modeling, provides a preview of how all your tables should connect, what fields are going to be on each table. What does it mean? I will be having a specific table. As you can see, a student table I have created. On that student table, what are the different fields? On the different fields, whenever I want to add a new field, I can add a field that is nothing but an attribute I can add to an entity. So adding and subtracting of entities in a ER model is very easy because it's a blueprint, as well as you can show how different tables are connected. So ER model helps to describe entities, attributes, and their relationship. So whenever we are going to consider any entity, we can have its attributes and how this entity is in relationship with other entities. So what is an entity? What is an attribute? What is relationship? In detail, I will be telling you in that video. So as ER model is a blueprint, they are transferable into relational tables which allow us to build database quickly. So as we know, we have this ER diagrams. These ER diagrams will be behaving as a blueprint. This blueprint, we can transfer the entire blueprint of this diagram into relational tables and we can create the database more quickly. So all these are logical. The database designers gains a better understanding of the information to be contained in the database. If we have the ER model with us, the database designer who is going to create the design of a database, they will be gaining more information or understanding the database design more easily and quickly. Let's see what is an ER model or what is an ER diagram. Both are same. ER model. ER model stands for Entity Relationship Model. Entity Relationship Model. Entity is a real world object relationship, how the real world objects are having a relationship among themselves in a database. So this model is used to define the data elements and their relationship for a specific system. For example, I have a company of some production. I have some production company. So in that production company, I will be having different departments on the different data elements. So how these data elements will be communicating among themselves will be specified in our database model. The ER model defines the conceptual view or design or blueprint of a database. Conceptual view or design or blueprint. It means that before creation of a database, before creation of a database, we'll be having how the database look like, how the database look like, how the different elements of a database will be communicating. So in detail, the ER model will define everything how our data elements will be having a relationship. So it is a high level data model. ER model is a high level data model used to model logical view of the system from data perspective. From data perspective. What is a data perspective? how the data should be visible, how the data should be visible, how the data should be communicating, how the data will be communicating with other data. So it's a high level data model purely based upon data perspective, having below components. What are these components? Entity is one component, entity type is one component, and entity set. So in detail I will be telling about what is an entity, what is an entity type, what are entity sets. So in ER modeling, database structure is portrayed as a diagram called entity relationship diagram. Whenever we are going to create a ER model conceptual view, it's nothing but a diagram. So that diagram is going to portray the basic structure, how our database look like, how our database look like. An entity relationship model, that is ER model, describes the structure of a database with the help of a diagram which is known as relationship diagram, that is ER diagram. ER modeling helps you to analyze data requirement systematically to produce well designed database. So without ER modeling, we cannot create a database. It will help us to analyze the data requirement systematically, to analyze the data requirement systematically, and based upon our analysis, we can produce well designed database as per the requirement. So let's see this example of ER diagram. Let's consider I have a table, student table. So physical table, I have a student table wherein I have columns or the field name such as student roll number, student name, and its phone number. Let's consider I have another table college where I have the fields such as college code, college address, and a phone number. Now, how these two tables are in relation? As we know, students will enroll into the college, will enroll into the college for to learn some course. So, we can say student studies in college. We can say student studies in college. So, studies will be the relationship between student table and college table. So, this is an table representation. Let's consider the same thing with our ER model representation, diagrammatical representation. Student table. So here student table will be called as student entity in relationship model, that is ER model. So student is an entity having the attributes student roll number, student name, and student phone number. So all these are attributes of our student entity. And I have a college entity. The attributes of college entity is college code, college address, and college phone number. All these are its college entity attributes. So this is my student entity and college entity. In the above, you can see student table and college table. So in ER diagram, we'll be having entities. So student entity and college entity. So student entity having its own attributes, college entity is having its own attributes. Now what is the relationship? The relationship is student is going to study in college. Student studies in the college. So studies will be the relationship between student and college. So this is a basic example of our ER diagram. Let's see geometric shapes in ER diagram. What are the different shapes we'll be using for creating an ER diagram? First we have this rectangle. So it is going to represent the entity set. Whenever we are going to see an rectangle in an ER model, it is going to represent an entity. So rectangle represents entity sets. Next we have the shape eclipse. Attributes, it is going to represent an attributes. It's nothing but our all shape. Next we have the diamond, which is going to show us the relationship set. Whenever we are going to have the diamond in between entities, it is going to show the relationship between entities or entity sets. Next we have this lines. So they link attributes to entity sets and entity sets to a relationship set. Next we have the double eclipse. Next we have the double eclipse. It is a multi-valued attribute. Single eclipse if you have, it's a simply attribute. If you have double, it is a multi-valued attribute. Next we have the dashed eclipse. It is a derived attribute. It is a derived attribute. What's a derived attribute? I will be telling you in detail about this attribute in coming slides. Next we have double rectangles. Next we have double rectangles. Whenever we see a double rectangle in our ER diagram, it's a weak entity. Double rectangle represents a weak entity set. Next we have double lines. Next we have double lines. It is going to represent total participation of an entity in a relationship set. How many different entities will be having in a participation of an relationship will be shown with the help of double lines. Let's see the components of ER model. So what are the different components? So in ER model, we have seen entity, attributes and relations. So these three are our major components. These three are our major components of ER model. So what are these components? Entity, attribute and relationship. So every entity will be having attributes. What is an attribute? It's a characteristics of an entity. Characteristics of an entity. So I have three components of ER model, that is entity, attribute and relationship. So let's see this entity. So entity is of two types, strong entity and weak entity. Strong entity and weak entity. Attribute. So attribute will be of four types. First, key attribute, composite attribute, multivalid attribute and derived attribute. Next, coming to relationships, I will be having unary relationship, binary relationship and n-ray relationship. With respect to this relationship, I will be having the cardinality constraints such as one to one, one to many to many to one. So all these are my cardinality constraints with respect to my relationships such as unary, binary and n-ray. Let's see the entity. What is an entity? An entity is a real world thing or an object which can be easily identified, such as person, place, or a concept. So here we will be having two types of entities. We will be having two types of entities. One is tangible entity, next is intangible. So coming to tangible, which exist in real world physically. Example, person, car, building, student, college, etc. Whereas intangible exist only logically, have no physical existence. Example is bank account. You cannot touch the bank account. It's a logical. So like this we have two types. So let's discuss more in detail about entity. So let's consider a pen. Pen is an physical object to which you can touch and feel. It's a tangible. So it's an entity. Pen is an entity. So as we know, every pen will be having certain characteristics. Every pen will be having certain characteristics such as name. Every pen will have a certain name like Uniball as you can see in the picture. Every pen will be having a barcode or a pen ID. Every pen will belongs to certain brand like Parker, Reynolds, Rotomac, like this. Every pen will be having its own type like ball pen, ink pen, gel pen, etc. Every pen will be having its price based upon its type and brand. So all these are the characteristics of the pen, of the pen. So pen is an entity. So how I can create an entity diagram of this pen? So let's See this pen. Pen is an entity. This pen is having its characteristics which are called as attributes, its attributes. So this pen is having its characteristics: name, barcode, type, brand, price. All these are its attributes. All these are attributes. Every entity, if it is tangible or intangible, in every entity we will be having two types: strong entity and weak entity. So here I will be telling you about strong entity. A strong entity will always have a primary key. What's a primary key? What's a primary key? Primary key is a key which uniquely defines each row in a table. So strong entity will always have a primary key. A strong entity is not dependent of any other entity in a schema. Strong entity are represented by single rectangle. Strong entities are represented by single rectangles. The relationship of two strong entities is represented by a single diamond. So various strong entities when combined together creates a strong entity set. If we have a set of strong entities, if I combine together strong entities, then that particular entity set will be called as strong entity set. What's a weak entity? Weak entity does not have any primary key. It means a weak entity is dependent on a strong entity to ensure its existence in a schema or a design or an ER diagram. A weak entity is represented by a double rectangle. The relationship between one strong entity and one weak entity is represented by a double diamond. So let's see strong entity and weak entity example. So I have a student, entity, and its attributes are student ID, student name. I have a grades, another entity that is a weak entity, and its attributes are grade ID and percentage. As we know, every student secures grade. So here I can say grades are purely dependent on students. So student is a strong entity. And its primary key is student ID. Whereas grades is purely depends on student. That's the reason grades is a weak entity. Student is a strong entity, grades are weak entity. Without students we cannot have grades, right? So that's the reason grades are purely depends on students. So student is a strong entity, grades are weak entity. So this is strong entity students, grades are weak entity. What's an attribute? What's an attribute? Attributes are the descriptive properties which are owned by each entity of an entity set. Every entity set will have attribute. As we have seen the example of a pen. Pen is having a characteristics. These characteristics are nothing but attributes. Every physical object or conceptual object or logical object which is considered in database will be having its attributes. So attributes are nothing but characteristics. For example, roll number, name, date of birth, age, address, mobile number are the attributes which defines the entity type student. So it means that whenever any student is enrolled for any particular course, it will be that student will be having a roll number, name, date of birth, age, address, mobile number. So all these are nothing but its characteristics of a student. So student Characteristics are nothing but attributes. So student will become entity type. All this roll number, name, date of birth, age, address, mobile number will be called as its attributes. So in ER diagram, attribute is represented by an oval shape. It is represented by oval shape. So there are four types of attributes, that is key attribute, composite attribute, and multivalued attribute and derived attribute. So what is key attribute, what is composite attribute, multivalued attribute and derived attribute, I will be telling in more in detail. So what are the different types of attributes? First is key attribute, next composite attribute, multivalued attribute and derived attribute. Let's consider more in detail about them. Key attribute, the attribute which uniquely define, that is primary key, each entity in an entity set is called key attribute. Coming to primary key and different types of keys, I have created detailed video on keys in database management system. So link is provided in the I button as well as in description. Please learn about keys from my video, keys and dependencies as well. So in ER diagram, key attribute is represented by an oval with underlying. For example, roll number will be unique for each student. So I have this student entity. So every student will be uniquely defined in a student database. How the students will be defined uniquely? With their enroll number, with their enrollment number. So this enrollment number is nothing but their roll number. So this roll number is a key attribute. This is roll number is an key attribute of this entity set or entity type student. Next we have composite attribute. An attribute composed of many other attributes is called as composite attribute. Is called as composite attribute. For example, address attribute of a student entity type consists of street, city, state and country. In ER diagram, composite attributes is represented by an oval comprising of ovals, such as I have the student here, entity type student is having student name as in one attribute and student address as an another attribute. So this address is a composite attribute, such as it is going to have all these again attributes inside that. Address field will be having again fields such as street, city, state and a country. So all this is nothing but our address attribute. They are going to represent the address attributes. So address attribute is a composite attribute, okay, which is a composition of all these different attributes. Next we have multi-valued attribute. An attribute consists of more than one value for a given entity will be called as multi-valued attribute. For example, phone number can be more than one for a given student. For example, home phone number and office phone number. So in ER diagram, multi-valued attribute is represented by double oval. So let's consider this student type entity having student name and student phone number. So student phone number is a multi-valued attribute. Multi-valued attribute. So phone number is a multi-valued attribute in this entity set. Derive attribute. An attribute which can be derived from other attributes of an entity type is known as derive attribute. For example, age. Age can be derived from date of birth. So if we are having an entity set, in that entity set, if I have an attribute date of birth, from the date of birth easily I can find out what is the age of a person. So in ER diagram, derive attribute is represented by dashed oval. So let's consider this entity's type student. having attributes student name, date of birth, and age. So here age is an derived attribute. How I am going to get the age? Age will be defined based on the date of birth of a student. So age is an derived attribute. Age is an derived attribute in this entity set. Let's see the last component of ER diagram or the ER model, that is relationship. What's a relationship? The association among different entities is called as a relationship. Is called as a relationship in our ER model. So we'll be having different entities in an entity set. How these entities will be having an association among themselves will be defined as an relationship. Will be defined as an relationship. So we will be having a relationship set. So what is a relationship set? We will be having similar kind of entities in an relationship set. For example, if I have an education institute, in an education institute I will be having a faculties, students, and courses. All these are three different type of entities of having the same subject concept, that is education. So if I have a relationship among these all, it will be called as a relationship set. They are of similar type. Next we have the degree of relationship. Next, we have the degree of relationship. The number of participating entities in a relationship defines the degree of relationship, such as unary, binary, and n-ray. So, unary means only one entity will be there in relation. Next, binary, two entities will be there in a relation. N-ray means more than two, that is three or four entity sets or entities will be there in a relationship. Next, we have the mapping cardinalities. Mapping cardinalities. Cardinality means how many times a one particular entity can be in association with other entity. For example, one entity can participate or have a relationship with another entity one time or two times or many times. For example, a student can enroll into multiple courses. So it means one to many, right? Next, a student can opt for a single university. So student is in one entity, university is one entity. So one to one. So like this, cardinality is going to define how many number of times an entity is going to be in association with some other entities. So relationship. So relationship is of three types: unary, binary, and n-ray. Unary means degree is 1, binary means degree is 2, n-ray means depends upon the how many types of how many different entities are there. Unary means only one entity will be in relation. Binary means two entities. N-ray means more than two. So next we have the cardinalities. In cardinalities we'll be having one to one to many to one, many to many. So this is called as my cardinality constraints in each relationship. In each relationship. So let's see the first relationship, unary relationship. When there is only one entity set participating in a relation, then that relationship is called as unary relationship. Is called as unary relationship. For example, one person marries to one person. Okay, one person is going to marry to another person. So one to one. So one person marries to another person. So this is person marries to person. So it's a unary relationship. It's a unary relationship. Next we have binary relationship. When there are two entities sets participating in a relation, the relationship is called as binary relationship. Binary relationship. For example, student enrolled in a course. Student enrolled in a course. So student is in one entity, course is in one entity. So these two are two different entity types or set. So student is going to enroll for one each course. So one student will be enrolling for a course. So it means enroll is an relationship. which is of binary. Two different entities are there in a relationship. So one is student entity, another is course entity. So this type of relationship is called as binary relationship, having two entities in a relationship of enroll. Next we have entry relationship. When there are n entities, it means more than two entities participating in a relation. The relationship is called entry relationship, where we will be having more than two entities. As you can see, I have entity 1, entity 2, entity 3, entity 4. So all these four entities are in some relation. So this type of relationship is called as entry relationship, wherein we will be having more than two entity sets are in relation. Next, we have the cardinality constraints. What's an cardinality constraint? Cardinality constraint is going to define how many times a one entity can participate in a relationship. Can participate in a relationship. So first type we have is one-to-one cardinality. First we have is one-to-one cardinality. When each entity when each entity in each entity set can take part only once in the relationship, the cardinality is one-to-one cardinality. The cardinality will be one-to-one cardinality. Let's assume a female can marry to a male. A female can marry to a male, right? So the relationship will be one-to-one. One female or one male can marry, right? So here I have a relationship between two different entities, that is male and female. So male marries to female or female marries to male, right? So this is a one-to-one cardinality relationship. This is one-to-one cardinality relationship. So it means both both these entities can participate in the relationship only once. In this relationship only once. So this type of cardinality is called as one-to-one cardinality. Next cardinality we have is many-to-one cardinality. In this, one particular entity can participate in a relationship multiple times, whereas other entity will be taking part only once in a relationship. So I will be explaining you with an example here. For example, I have a student entity set and a course entity set. Let's consider this course is provided from the university. So and students we have, so one individual student can participate into one single course. So like this, I will be having multiple students. I will be having student s1, s2, s3, s4. So it means many students will be enrolling for a single course, that is MBA. So this type of enrollment or the association or the relationship is enroll. So many students can enroll for single course. This type of cardinality is called as many to one cardinality. So n number of students will be enrolling for single course. N number of different students will be enrolling for different course. This type of cardinality is called as many to one cardinality. Next we have many to many cardinality, wherein whatever the number of entities we have, all the entities or number of entities will be participating or will be having an association in relationship multiple times. I will be explaining you this with an example. I have a student entity and a course entity. For example, I am having my own private institute wherein I will be having different courses, right? Private institute I am having very different courses I will be having. So the number of students will be more, right? So I am taking different students from s1 to s4. So likewise I will be having different courses such as c++, java, c sharp, web technologies. Different courses I will be having. So students will be enrolling for different courses. So it means that a one particular one particular student can enroll for two or more than two courses, or two student can enroll for same course, vice versa, right? So there is no restriction of enrollment of students from course or course to student. So n number of times student can enroll to different courses, same courses, or different courses, or combination of courses. So this type of cardinality is called as many to many cardinality relationship. This type of cardinality relationship is called as many to many cardinality relationship. Let's see the quick recap of this session. What's an ER model? ER model defines a conceptual view or a design or a blueprint of a given database. So before creation of a database, we have to go for the any model. The model which we are talking here is ER model. So ER model is a conceptual view or a blueprint of a database, how our database will look like. So in this, we will be having three components: entity, attributes, and relationship. So what's an entity? An entity is a real world thing or object can easily identify, like person, place, or a concept. What's an attribute? Attributes are nothing but the characteristics of these entities. Every person will have a name, age, gender, like this. Every place will be located somewhere having its own attribute. In the concept also we will be having a different attributes. So what's an attributes? Attributes are the descriptive properties which are owned by each entity of an entity set. So each entity will be having its own attribute. Next we have the relationship. Next we have the relationship. The association among entities is called relationship. Is called relationship. So in quick recap, let's see the components of ER diagram. The components of ER diagram are three: entity, attributes, and relationships. Coming to entity, entities are of two types: strong entity and weak entity. Strong entity and weak entity. Strong entity will be having an key attribute in that, that is primary key, whereas weak entity will not have primary key in it, as well as weak entity always depends on strong entity whenever it is there in an schema or a entity set. Next we have attributes. In attributes we have key attribute, composite attribute, multi-valued attribute, derived attribute. What's the key attributes? Key attributes is nothing but a primary key attribute. Next, composite attributes is a combination of some other attributes such as address. Address is a combination of street, door number, locality, district, state, country, like this. So address will be a composite attribute. Multi-valued attribute is nothing but a phone number. A person can have multiple phone numbers. So multi-valued attribute. Derived attribute is an age. On the basis of date of birth, we can derive the age. So age is an derived attribute. Next, we have the relationship. In relationship, we have three types: unary, binary, and n-ray. Unary means only one entity set will be in n relationship. Binary means two entity set will be there in n relationship. And n-ray means more than two. So these are nothing but a degree of relationship as well. So to have this, we will be having a cardinality constraints. Cardinality constraint will define how many number of times one entity set can take part into an relationship with some other entity set. So cardinality will be having one to one cardinality, one to many many to one cardinality, and many to many cardinalities. So these are nothing but our cardinality constraints. So in coming video, I will be discussing more in detail about different concepts of database management system. Thanks for watching this video. Thank you. Please subscribe to my channel, like and share my video. Thank you.